Hello all, myself Anil Kumar Chitiprolu. I have total 15 plus years of experience in working with various technologies, various domains, with various MNC companies. Currently, I am living in the USA. Today, I am going to present building self-healing APIs, intelligent monitoring, and auto-scaling for continuous API availability. What it means? APIs. Before we start, we know about these building self-healing APIs. I wanted to give you 30 seconds background about the APIs. APIs means a communication services where it can accept the incoming request and res- response to the incoming request based on the incoming request. These days, to communicate to provide the communication among the systems, APIs plays a crucial role. So, let it be internal communication of the company or the organization or external communication between the client and the organization APIs. Whatever it is, APIs plays a crucial role. In order to make sure our API is always available, we wanted to keep monitoring API's health. What will happen? Because of monitoring API's health, we make sure my API is always available. It can respond to any request coming in at any time across the globe. So, do we think monitoring API's health itself is enough? I don't think so. So, what it requires extra effort to make sure our API is available 24 by 7. I feel, along with the monitoring tool, if there is any issue in the API, which means for any reason, if the API is down, it should have the capability to auto scale and it should have the capability to recover itself using the new framework, and it should ready to serve the incoming request to that APIs. So if you have such tool, automatically those tools will help APIs to be available and make sure the communication network among the systems never be down for any reason. So, the challenge of modern APIs these days, what are the challenges? Basically, as I mentioned, it should be available 24 by 7 round the clock for all the global customers, and it should be the latency and the performance of all these modern APIs. We should make sure it is available. So, if any API is down, for example, if my organization is exposing 10 APIs, 5 internally and 5 to the external customer, if 2 of the APIs are down, then the incoming request which it receives from the external clients or the internal clients, it may not provide the sufficient response to the users, and users who don't know what will happen in case if the API is not responding properly, then the developer from the caller side or the external client or the internal client, they have to manually intervene what went wrong, and they have to raise a ticket that has to come to our team. Product owner or the scrum master has to assign the ticket to the developer, and then developer needs to work. The whole software ticketing life cycle will involve here and takes a lot of time. The turnaround time will be too much high. In the case of very highly impactful APIs, these days availability of API is very, very important. For that, we have come up with a solution of monitoring and auto scale healing. What it means, let us see in the further things. What is self-healing API? Self-healing API mainly concentrate on it automatically executes corrective actions, and it detects and diagnoses any failures in the current API for any reason if it fails, and it responds autonomously builds resilience. What it means? We will deep dive into each thing. Detects and diagnosis. Self-healing API means it continuously evaluates health signals at a very regular based on your API, how frequently you get the what quantity of incoming network load. Based on that, you can configure the internal continuous health signal monitoring. What it means, for example, if your API is very critical and even a 5 minutes down of your API will make big impact. So every 2 minutes you keep checking the health of an API. So it this because of this monitoring, it if your API is not so much impactful, even if it is down for 1 hour, then you can continuously monitor these health signals for every an hour also. So it checks for the latency, error rates, dependency failures in real time without manual intervention. Responds autonomously. It triggers an automated remediation. It retates circuit breaking or the traffic rerouting or scaling problems or CI/CD pipeline issues or the container Docker container or the Kubernetes containers problems. Whatever it may be, it automatically whenever whenever any API container or the server goes down, it automatically make the another server or the container up and running for the another external client or the internal clients. Builds resilience. What it means? It shifts teams from reactive firefighting to proactive reliability, reducing MTTR and increasing system confidence. Core self-healing capabilities, continuous monitoring, anomaly detection, automated failover, elastic scaling. So by the name itself, you can see that continuous monitoring, as I mentioned, every 5 minutes, 30 minutes, 15 minutes, 1 hour, you can keep checking the health of the API and automatically you will keep getting the report and anomaly detection. So it automatically identify deviations before users notice. Automated failover, reroute traffic to healthy replicas instantly. So containers are the servers, elastic scaling, dynamically it matches the infrastructure to demand. For example, if your APIs are getting too much of traffic on special occasional days, you can automatically increase. You can set up in such a way that you can your containers of the servers automatically increase to serve the need of your network traffic to handle the on the specific days. Intelligence monitoring, the foundation. So intelligent monitoring correlates telemetry across multiple operational layers, not just individual metrics to distinguish isolated anomalies from genuine service degradation. So you can say application metrics, structured logging, synthetic transactions, distributed traces, health endpoints, user experience data, real-time anomaly detection. So statistic thresholds generates noise. Intelligent detection identifies deviations from normal behavior using ML, statistical baseline, and seasonal trend analysis. Response time spikes, resource exhaustion, dependency degradation. So automated recovery workflows. So it detects anomaly, isolates the failure, execute recovery, validate the restoration. Recovery actions in practice: container restart or traffic rerouting, configuration rollback, queue draining. Here, container restart is the very much focusable point. It resolves transient software issues without affecting healthy workloads. When I say healthy workloads, say if your service is running in 5 containers, if one container goes down for any reason, automatically another container will pop up and it will up and running for the incoming request to respond back. And traffic rerouting, usually in the occasional days like Christmas, New Year days, if you are expecting a very high huge traffic to your APIs, and if you want to reroute a few of the traffic to the newly added servers on this occasion to handle this huge traffic, then it automatically reroutes the traffic also. Configuration rollback. So as I mentioned in the previous slides also, in case any container goes down automatically, you configure in such a way that minimum these number of containers at any given point of time, it should be keep running it. So queue training, safely complete async operations before restarting affected services. Adaptive auto-scaling. Fixed capacity breaks under pressure. Adaptive scaling eliminates that fragility, automatically matching infrastructure to demand in real time. So your system stays resilient and cost efficient. Scale out on demand, scale in intelligently, resilience under pressure. Scale out on demand means like whenever the huge traffic is coming, you can increase the number of containers or the number of servers. After the traffic has been reduced on the occasional days, it automatically scales in intelligently so that you can save some bucks on the infrastructure of your service. So you need not to pay for the entire year. Resilience under pressure. Auto scaling acts as a first line of defense during recovery, absorbing redistributed traffic when services fail on restart. Scaling strategies. So scaling signals. So basically, whenever any API is not responding, the number of how many number of times it is not responding, based on that it you can all configure using this system. So you can configure how many number of after how many number of downtime signals you can make the another service up and running, or another container or the server. So you can configure all these things in this framework, using this framework. So cloud native architecture layers. First, the infrastructure, like compute, storage, networking, cloud resources, or the etc. And orchestration, intelligence, observability, and presentation. Operational challenges and best practices. Balancing automation and control. Aggressive recovery policies can amplify instability. Implement cool down periods, dependency awareness, and recovery prioritization to avoid cascading failures. Observability quality. Missing telemetry procedure produces inaccurate decisions. Comprehensive instrumentation across all layers is essential. Security. Recovery workflow must enforce authentication, authorization, and audit. Future directions. Predictive analytics. Identify infrastructure risk and degradation is visible. AI enhanced detection. So distinguish true failures from temporary fluctuations with greater precision. Autonomous optimization. Continuously tune configs, resources, and routing without manual adjustment. Digital twins. Model production environment to safely evaluate recovery strategies before going live. Building resilient API platforms. So self-healing APIs combine intelligent monitoring, anomaly detection, automated recovery, and adaptive scaling into a unified framework, reducing downtime, accelerating recovery, and enabling organizations to deliver reliable digital services at cloud-native scale in the form of APIs. So, what it mainly focus observe, detect, recover, and scale. And these are the four pillars for this framework. So, as I mentioned in the previous slides also, this framework will mainly concentrate on availability of API round the clock throughout the globe. So using these kind of API frameworks, your API will be always, your APIs are always available, even if the downtime is there for any of the API. Without the developer intervention, it automatically recovers from the failure. If not, it automatically up and running with another container or the another server. That's all about my new framework. And if you have any feedback or questions, you can ask me at any time, or you can reach me in the email. So, thank you. Thank you all for the presentation, giving me this opportunity. Thank you all.